into controversy as Gossett does the common sense thing, which is to give the characters of the alphabet, but because he has committed, in my opinion, erroneously, to referring to sigma not as the alphabet but as the set of terminal symbols, he now doesn't, tell you that lambda is one of the terminal symbols. And therefore, some students have panicked, oh, what do I do now? How do I write this grammar without using lambda? Somehow I'm not allowed to use lambda. And the answer to this problem is, nah man, you can always use lambda. Lambda is always one of your available terminal symbols, and even though the alphabet is AB, feel free to use lambda whenever you want as one of your terminal symbols. And so, why do I want to use lambda? Because I kind of need to use lambda in order intuitively to capture this language. This language is the set of all strings that don't contain BB. Well, it just is true that the null string does not contain BB. So the null string just is a string of this language, and so I do need to generate it, and the only way to generate it is to do this. And so that sort of proves to you that we sort of need the null string to write the grammar for this language, and that means we have to have a rule like this, and I hope you all agree that it would be stupid to describe this problem by putting lambda in that set. Lambda sort of doesn't belong in that set. It's of a different philosophical status than the actual characters A and B that are characters of the target language. All right. Woo, look at this extremely high-level intellectual discussion we are having. Discussion in air quotes. Good. What the hell was I talking about? Yeah, I was writing this grammar. And okay, so now we did it, the first line. Now we go to A, and okay, in A we have a lot of freedom because what does A? I said already 5 minutes ago that I should think of big A as being, as representing my previous character was an A. And so if your previous character was an A, well, you can just write an A again because there's nothing wrong with having AA. Or you can write a B. But if you write a B, you have to now go to the state of I just did a B. You can also just stop at any time. So this just is a way to just terminate. And finally, we get to sort of the important one, which is if you just wrote a B, then you can't write a B next. So you either you basically have to write an A, or you have to just stop. And that grammar just intuitively just does the job, so we're done. Okay. Good. 2 more to go. 9C. Uh-oh. Did I assign 9B or 9C? I assigned 9C. That's kind of sad. But I myself solved 9B. Wait. This is brilliant, brilliant video happening here. Yes, I did assign 9C. Okay, so I'll do it on the fly. How hard could it be? I am an expert on this topic. What is 9C? It is the following language, where once again we have the same sigma. And the language is everything of the form A to the K, B, B, A to the M, where K is greater than or equal to 1, and M is greater than or equal to 0. Okay. Oh yes. Let's go. Well, okay. Let me think about this for a second. Okay, so it's kind of like this. I need sort of freedom in 2 ways. So, okay, maybe this is not so hard, but maybe it is. Okay, so yeah, here we go. We're going to just drop an A out front because I need at least 1. And then we're going to go to this new state X. and x is the state of I have just fulfilled my minimal obligations regarding how many A's are at the front of this string. And what are we going to do in this state x? We are either going to make more A's or we're going to get on with the rest of the string. And so we can make more A's and go back to x, or we're going to make a B and we're going to get on with it. But actually, we might as well, what is the meaning of get on with it? The meaning of get on with it is we go to B, B, and then some number of A's. So, just thinking a little bit here. Yeah, so I go A, X, and then I can hang out in X, just pumping out A's, and when I'm done, I go to B, B, Y. So that's going to give me at least A, B, B, Y, and then what should I do in Y? Well, in Y I'm just going to make some more A's or not. So this is just going to be A, Y, or lambda. That, I feel very strongly, must be right. The only way to end this string is after I've gotten through this BB section, and Y allows me to end it immediately or to just stay in Y making A's, and this is just good. Very happy with that. Okay, 15. 15 is just a cute little problem, which is maybe kind of silly, I now think. Find a grammar whose language has more words of length 3 than it has words of length 4. Okay, well, one kind of stupid answer to this is, hey, I got a language for you which has more characters of length 3 than characters of length 4. How about the grammar with a, or the language, which consists of only the string AAA. Alright, so sigma in this case has just got one character in this alphabet, and I got one non-terminal symbol, and it only does one thing. So that's a finite language. In fact, it's a language of size 1, and it has one character of length 3 and no characters of length 4. Okay, so that's just like fine. What if you wanted your language to be non-trivial? Which is to say, infinite, well then I can still do this. It's still kind of a little maybe disappointing. Let's again have a unary alphabet, because why not? And now I just go, S goes to A-A-A-S. And what does this? Once again, I have one non-terminal, and what does it do? This is, the language of this is going to be all the strings such that there are some multiple of 3 number of A's. So this is going to be W to the W is going to be, it's going to be all the strings W such that W, well, I don't know if I need a W even, it's just going to be all the strings of the form A to the 3n, where n is greater than or equal to 1. No, I suppose I need to be able to end this at some point. So, or lambda. That was almost a mistake. Or lambda. So now, does that work? I guess it just does, right? I can just do nothing. So I have the null string, or I can make AAA, and then I can keep ending or making more. So what is this? This is a language of where all strings are composed of A's, and there's always a multiple 3 number of A's. And so once again, this language has one string of length 3, but no strings of length 4. Okay, woo! Hopefully that homework wasn't too bad. If you're doing this in chronological order, you are now going to, which sort of is not what I think you should do, you're then going to learn about regular expressions, even though I've been using them during this video, kind of. And then you're going to learn about non-deterministic finite automata, and then you're going to learn one more thing about them. Okay, goodbye.